Solve the following system of linear equations using Gauss-Jordan elimination method. So when we're getting simultaneous equations here, we are going to write in metric forms. So the coefficient here will be 1, -3, 1. So for second equation, 1, 1, 1. Third equation, 2, -1, 1. Unknown metric x, y, z. And answer is -12, 0, -8. So when we want to solve this, finding x, y, z using Gauss-Jordan elimination method means we are going to use the technique of ERO, elementary row operation. The first step, we have to form out our augmented matrix. So our augmented matrix will be put in our matrices here and then separate by our answer, which is -12, 0, -8. So this is our augmented matrix. So in order to find our unknown x, y, z. So we will apply our ERO on this row so that our left hand side matrix A will change to identity. Automatic for this side, the value appear here will be our result of x, y, z. So to perform ERO, elementary row operation, we need to change the place of 0, which is row 2 and row 3. And then we need to fix our row 1. So after we forming our augmented matrix, we will fix our row 1. So row 1, nothing going to change. We only change for row 2 and row 3 so that this entry will be 0. This entry will be 0. So the row 2, when you need to change, it will be row 2 star equals to row 2 will be operate with row 1. So our row 2 value here is 1. Row 1 value also 1. So we can just minus to get 0. So the operation here will be row 2 minus row 1. So row 2 is 1, 1, 1, 0. Row 1 is 1, -3, 1, -12. So we minus it, we'll get 0, 4, 0, 12. So our new row 2 result is 0, 4, 0, 12. Then for row 3, we need to change to obtain 0. So row 3 also will operate with row 1 because row 1 is constant. It doesn't change. So that's why we use row 3 operate with row 1. So for row 3 and row 1, our row 3 here is value 2. Meanwhile, row 1 is value of 1. To obtain 0, here we need to times 2. And we perform the operation of minus. So the row operation that we did here will be row 3 minus 2 row 1. So we take out our row 3 here, 2, -1, 1, -8. Time with 2 for row 1, 1 times 2, -3 times 2. Then 1 times 2, and then 24. So we're going to minus. Here we get 0, 5, -1, 16. So we done for the first step where we get 0. Then we continue to the second step. We need to change 1, 2 and 3, 2 to become 0. So here we're going to fix our row 2. So from here, row 2 we're going to fix it. It doesn't change. We are going to change row 1 and row 3. So row 1, you need to change, you need to operate row 1 with row 2. So row 1 and row 2. We will cross multiply the coefficient here. So here times 4 and times 3. So negative, positive. Our operation here will get 4R1 plus 3R2 so that we can obtain 0. So we operate for the whole row where 4R1. So this row 1 you need to times 4. Row 2 we're going to times 3. Add on together. So here we have 4, 0, 4, negative 12. Continue. The next row that we need to change to 0 will be the position of 5 here. So it will be in row 3, we need to change. So row 3 will need to operate with the constant row, which is row 2. So row 3 and row 2. Row 3 is 5, row 2 is 4. So we times 4, here is times 5. Then we minus. So the operation for this row will be 4 row 3 minus 5 row 2. So this row 3 will go into times 4. And then this row 2 will go into times 5. And then they need to minus. So here we have 0, 0, negative 4, 4. Then third step, we're going to change here to be 0. So since here already 0, so we don't need to change anymore. Now the constant row that didn't change will be row 3 and row 2 because row 2 already obtained 0 in the position. So now we're going to change row 1. So row 1, if we want to change, we need to operate with row 3 because now our constant will be at row 3. So row 1 value is 4. Row 3 value is negative 4. So we just add up to get 0. So row 1 plus row 3. Operate for the whole row. Row 1, 4, 0, 4, negative 12. Row 3, 0, 0, negative 4, 4. Add up. So here we get 4, 0, 0, negative 8. So to get identity pattern, we already obtained the entries of 0. Now we're going to do this diagonal so that we can get identity in the value of 1, 1, and 1. So lastly, we're going to divide this value of 4. To obtain 1, we're going to divide by 4. So for this row 1, we will divide by 4 for entire row. For row 2, also divide by 4 for entire row so that we can get 1 here. For row 3, we're going to change and divide it by negative 4. So here we get our new row, divide by 4. It will give 1, 0, 0, negative 2. Meanwhile, for row 2, also divide by 4. So it will give you 0, 1, 0, 3. So for the third row, divide by negative 4. So it will be 0, 0, 1, negative 1. So here we obtain our identity at left hand side. So the value that appear here will be our solution of x, y, z. So therefore, x will be equal to negative 2, y will be equal to 3, and z will be equal to negative 1. So this will be our solution for our linear equations.